Alright, so we're supposed to solve each equality and graph the solution set on a number line. So the first thing you should always remember, if you have either a polynomial, it doesn't even have to be a quadratic, it could be any polynomial degree 2 or higher, or a rational, which is a fractional equation over here with a variable in the denominator, you need a 0 on one side. If you do not have a 0 on one side in the outset, go ahead and get that handled. That's step 1, get a 0 on one side of the inequality. Step 2, factor if possible. This factors. You remember what you can do. The long way of factoring it using the AC method. You can multiply 2 times 3 together, and that gives you -6, 2 times -3. And you're trying to find numbers that multiply to equal -6 and at the same time adds to equal 5. What two numbers do that? How about a +6 and a -1? You agree those multiply to be -6 and they add to be +5. It's the only numbers that'll do it. You can play around with 2 and 3, but your signs won't work out right. Now what you're trying to do is rewrite the 5x in the middle. So I rewrite this as 2x squared plus 6x minus 1x minus 3. I replace the 5x with these two numbers. Of course, I put an x with them, just like as with the 5. Then you do factor by grouping. So these two group together, a 2x factors out, and that leaves you x plus 3. When these two group together, a -1 factors out, and that leaves you with the same common x plus 3. You pull that common x plus 3 out, and you're left with 2x minus 1. So really what I'm doing here is you'll notice that the greatest common factor, once again, is x plus 3. I pull that out. It's right there. You only write it once, and you're left with the values out front, the 2x and the -1. Okay? Now, you didn't have to factor it that way. Don't feel like you have to do that. If you're comfortable factoring just trial and error, this one works fine that way. So you just do your 2 sets of parentheses and less than 0, and you play around. The only thing that multiplies to give you 2x is 2x and x, right? The only thing that multiplies to give you 3 is 3 and 1. You've just got to figure out where to put the 3 and 1. So if you put the 3 here and the 1 here, notice 2x times x is 2x squared. 1 times 3 is 3. But you've got to get the middle term. So 2x times 3 gives you 6x. So this needs to be plus, and then you need to minus that 1. But that's what you have to kind of play around with, is where does the 3 and 1 go? Because you might have tried the 3 here and the 1 here, and that wouldn't work at all. Now, what do I do? Now, please, please, don't separate these and say 2x minus 1 is less than 0, x plus 3 is less than 0, boom, you're done. Doesn't work that way. The next thing you need to do is draw yourself a number line and find where it's equal to 0. Like here, if I add the 1 and divide by 2, so I set 2x minus 1 equal to 0, I add the 1, divide by 2, and you'll see I get x is equal to 1/2. Here, I set x plus 3 equal to 0, subtract the 3, and you get x is -3. These two zeros belong on your number line down here, so -3 is smaller than 1/2, so I make sure I put the -3 on the left. Now, these values will not make this inequality true because there's no equal to here. These values make it equal 0, but equal 0 is not an answer, right? Because it says less than 0. So I put open circles there. If there were an equal to down here, I'd fill those circles in. The next thing is I need to test points to determine where to shade. So I'm going to check x equals -4. That's to the left of -3. I'm going to pick something in the middle, for instance, x equals 0. And then I'm going to pick something on the right, for example, x equals 1. So make sure you pick an interval on the left, an interval in the middle, and an interval on the right. If there's 3 separate intervals you have to check. If there's more, you got to check more. Where am I plugging that in? Either in the original inequality, or the factored one is a little bit easier. So I'm going to plug it in the factored one. That's 2 times x is -4 minus 1. Times -4 plus 3. And y'all, all I'm trying to determine is that true or false. Is that less than 0? Well, 2 times -4 is -8 minus 1 is -9. -4 plus 3 is -1. Is that less than 0? No, it's not. This is a false statement. So this, not part of my answer. Let's check 0. I'm going to change colors on you to check 0. just so you can see all the work easily. So I'm checking 2 times 0 minus 1, and then 0 plus 3. And really, this could be done in your head as long as you're getting them right. Now you're checking to see, is that less than 0, just like the problem says. This is -3 is less than 0. Is that true? Sure it is. If it's true, let's shade that interval in. That is part of my answer. Everything in that interval will make my statement true. And then I'm going to change colors on you again to check this other side over here. X equals 1. So that's 2 times 1 minus 1 times 1 plus 3. Is that less than 0? Well, 2 times 1 is 2 minus 1 is 1. 1 plus 3 is 4. Is 4 less than 0? No, it's not. This is false, right? So everything in that interval is going to make it false. Not just one, but every number. So how do I write my answer? In interval notation, I'm going to write it in orange since that just happens to be the interval that was correct. You can't include the -3 or the 1/2 because those values aren't included because that would make it equal to 0. And there is your final answer there. Okay, let's try it again a bunch more times. Okay, so once again, will it factor? It's a quadratic, so you could just plug these values into the quadratic formula and figure out what goes on your number line immediately, but I try to give you problems that factor for this particular situation, so we can factor this again like we did the last one. Because the leading coefficient's 2, it's not as easy to factor. We're trying to find numbers that multiply to equal 8. Again, 2 times 4. Also adds to equal 9. Now we know numbers that do that are 8 and 1, both positive. So I rewrite my initial polynomial, 2x squared. I take out the 9x and I replace it with 8x plus 1x plus 4. Then factor by grouping. So 2x comes out of the first set and that leaves x plus 4. All you're doing is pulling out a 1 out of the second set because we already have an x plus 4. Then factor out the guy that matches, x plus 4 times 2x plus 1. You'll find if you get used to factoring that way a lot, it's faster than trying trial and error. To me, it definitely is. So this is what we have to deal with. Again, don't set each one of those greater than or equal to 0. That is not right. What you got to do is find the zeros. If I set x plus 4 equal to 0, get x equals -4. If I set 2x plus 1 equals to 0, get x equals -1/2. So there's my -1/2, and there's my, I did that backwards. -4 is smaller than -1/2, isn't it? -4 and -1/2. Now this time, because I have a greater than or equal to 0, I need to fill in these spots. Why? Because -4 makes my polynomial equal 0. Well, that's a valid solution because it says equal to 0 is allowed. The last problem, there was no equal to, so I couldn't include those values. Now I'm going to test points again. So the first thing I'm going to do is change colors so it's easy to see. I'm going to test, how about x equals -5 right here. Something in between -4 and -1/2. Let's go with x is equal to -1. That'll work. And then something on the other side over there, a number that's bigger than -1/2. My favorite number to test is x equals 0. It's definitely bigger than -1/2. So if I go back to the -5, I'm just plugging that in my factored inequality. You could plug it in the original too if you want to. Factored is just faster. So -5 plus 4 times 2 times -5 plus 1. Again, you could do that in your head if you want to. We're trying to see if it's greater than or equal to 0. That's -1 in the first parentheses. That's, -9 in the second parentheses. That's -10 plus 1, yeah. Is that greater than or equal to 0? Is 9 greater than or equal to 0? You bet it is, right? That's a true statement, so I shade that in. Now when I check x equals to -1, all right, so I've got 2 times -1 plus 1. Why I plugged that in the second one first, I don't know. I think that's just where I looked up. -1 plus 4, I wrote it backwards, y'all. But the work's the same. 2 times -1 is -2 plus 1 is -1. -1 plus 4 is 3. Is -3 greater than or equal to 0? It is not. Nope, it's not. So I cross that out. And then I'm plugging in 0. Right? So that's going to be 0 plus 4 times 2 times 0 plus 1. Is that greater than or equal to 0? Well, we got 4 times 1. Is that greater than or equal to 0? Yep, 4 is greater than or equal to 0. That's true, so I shade this in. So this time my final answer is going to be negative infinity to negative 4 with a bracket because negative 4 is included. And then union, negative 1/2 to infinity for the part on the right. Now, again, the union symbol in the homework, not sure about that. Might be a comma, but I like the union symbol. All right, another inequality. Notice it has an x to the third. Is that okay? Yeah, sure it is. What's not okay is this 3x over here. I need a 0 over there. How do I fix it? I move this guy, well, my pen work, to the other side. So I got x to the third plus 2x squared minus 3x when I move it to the left is greater than 0. Now there's a greatest common factor there. Let's pull that x out. So that's x squared plus 2x minus 3 is greater than 0. Hey, that'll factor. So what multiplies to be negative 3 and adds to be positive 2? Well, y'all, that's a plus 3 and a minus 1, right? Y'all, when I do my number line, I'm going to do it at the top over here so I have room underneath it. Not that I have to. I need to put the zeros that I come up with here. Now, don't forget about your lonely x out here. That gives you x equals 0. This second factor gives you x is equal to negative 3, and the third factor gives you x is equal to 1. Am I just changing the signs? Well, sort of. Really, in my head, I'm setting that equal to 0 and subtracting the 3 over. I'm setting x minus 1 equal to 0 and adding the 1 over. Okay? In order up here, smallest on this list is negative 3. Next smallest on the list is 0. And then next is 1. Now notice I don't have this to scale because I'm not really concerned about that. I'm just trying to test intervals. So I'm going to play with my colors again because it's fun. And I'm going to make green over here. Y'all pick a number over here you want to test. I'm thinking about x equals negative 4. Pick a number between negative 3 and 1 you want to test. And I'm thinking in orange about x equals negative 1. You could have picked negative 2 if you want to. Something between 0 and 1, and you might think there's nothing between 0 and 1, but that's so not true, right? There's an infinite amount of values between 0 and 1. We just want to pick one of them. Decimal is fine. How about 0.5? Or 1/2 if you like fractions a lot, okay? And then something on the other side of 1. Don't forget that other side over there. And what color have I not used? Some kind of blue. How about that? How about x is equal to 2? Okay, and what am I going to do? I'm going to plug them in this factored version and just see if we've got a true or a false statement. Now, y'all, I'm going to do some stuff in my head here. Watch this. Over here for negative 4, if I plug negative 4 into this x, that gives me a negative number. If I plug negative 4 into x plus 3, that'd be negative 4 plus 3. That's going to give me a negative number. If I plug in negative 4 right here, negative 4 minus 5 is negative 5. That's a negative number. Now, notice I left the number off. I just wrote the sign. But y'all, a negative times a negative times a negative is overall a negative. Are negatives greater than 0? No, they're not. Positives are greater than 0. So, without even thinking about the numbers, I have tested negative 4. See how I'm doing that? Let's try it again with negative 1. Okay? So, I'm taking negative 1, and to save myself a little bit of work, I'm taking negative 1 and plugging it in just this factor of x. Well, that's going to give me negative 1. What matters is that it's negative. If I take negative 1 and plug it into negative 1 plus 3, I get positive 2. How about we just put positive? If I take negative 1 and plug it into x minus 1, negative 1 minus 1 is negative 2. That's negative. Greater than 0. Now, y'all, a negative times a positive times a negative is overall a positive, isn't it? Because these two negatives turn positive. So we don't even care what the number is. It could be positive 1/3 or it could be positive 1,000,000. It's greater than 0, so I shade that part in. Do you know what I forgot to do? I know you see it. I forgot to put open circles or closed circles on my zeros. They're all open. Why are they open? Because the original problem was simply a greater than, no equal to there. Now let's check 0.5. Decimal, you say, is that bad? This is perfectly fine, especially using the little trick I'm showing you. So if I plug 0.5 into just this x over here on the left, I'm looking in this big rectangle here. If I plug in 0.5 there, that's positive. If I plug in 0.5 there and add 3 to it, that's positive. If I plug in 0.5 there and I subtract 1, that's negative, right? 0.5 minus 1 is a negative number. Okay, is that greater than 0? Well, positive times a positive is a positive times a negative is a negative. Greater than 0. It's not, right? And then let's check 2. So change my fancy colors. Okay, 2. If I plug 2 into this x on the left, it turns out positive. If I plug 2 into x plus 3, it's a positive 5. It's positive. If I plug 2 into x minus 1, 2 minus 1 is 1. It's positive. Are all those positives greater than 0? Yeah, that's a true statement. So I shade this piece right here. Okay. Now, my interval, it is what's shaded. So let's see if we can write down what's shaded. Let's see if we can pick a color. All right, so the first thing from the left to right that's shaded is -3, but I need a parenthesis around it because the -3 is not included all the way up to 0, and then it stops. And then it picks back up at 1, but with a parenthesis because the 1's not included all the way to infinity, and there you go. So a polynomial, first we got it to 0, then we factored it all the way down, and then we tested points as quickly as we could using the little tricks. Okay, we'll keep using the tricks and see if that will help you do these problems. Now, if the trick makes no sense to you, just pause it. Literally plug those numbers into the factored version and compare what I'm showing you. It's just you're multiplying. I'm using rules of multiplication of signed numbers. And so a negative times a negative is always a positive. And a positive is greater than 0 is true. A positive less than 0 is false. Okay? All right. Again, let's try on the next one. Now, this is our first rational in the homework. Is it harder? There's just one thing you've got to remember. Now, the first step, is there a 0 on one side? You bet. So step 1's done. The next step is to factor. You know what? We're already there too because x minus 6 and x plus 2 are linear. They're not going to factor any further unless they had a greatest common factor, which they don't. Okay? So then the next thing I do, I'm ready to draw my number line. So there we go. There's my number line. What goes on it? Well, if you set the numerator equal to 0, you get x equals 6. So x equals 6 goes on my number line. If you set the denominator equal to 0, you get x equals -2. So that goes on my number line as well, in order. So -2 goes on the left, 6 goes on the right. Now, because it's a greater than, there's no equal to, then we have open circles here. But let me tell you, that only applied to the 6. So the one that comes from the numerator, you look to your inequality to decide whether to fill it in or not. The 0 that comes from the denominator is always going to be an open circle. It does not matter what inequality you get because this is undefined at -2. I'm never allowed to plug -2 into this particular rational expression. Okay, now let's test points. What do you want to test? How about we pick, I don't know, -3 on the left. How about 0 in the middle? And what about 7 on the right? There you go. Now, watch my trick, okay? Again, as long as you are factored, okay, and there's only one term, there's 2 terms in the numerator, but you can think about that as one factor up here and one factor down there. So we can do our trick. Let me show you what I mean. So if I take -3 and plug it in the top, now that's, I'm going to do it the long way first. And I'm also going to make sure my color is right. Okay. If I plug in -3 in the top, that's -3 minus 6 divided by -3 plus 2. -3 minus 6 is -9, right? -3 plus 2 is -1. -9 divided by -1 is +9. Remember what we're trying to do, we're trying to see if it's greater than 0. Now that's true, right? So I'm going to shade it in. But that took a lot of writing and more work than I wanted to do. So let me show you what you do. You take the -3 in your head, you plug it in on top, you get a negative number, right? Take the -3 in your head, you plug it in the bottom, and you get a negative number. And negative divided by negative is a positive, and positive's greater than 0. That's true. Look, all the work was right there that I did right there. So let's try it with 0, but just use the trick this time, okay? So if I take 0 and plug it in the numerator, I get a negative number. I get negative 6. If I take 0 and plug it in the denominator, I get a positive number. Happens to be 2. Now, a negative divided by a positive overall is a negative. Are negatives greater than 0? They're not. This is a false statement, so I don't shade in that interval. Let's try it again with 7, okay? Now, 7 plugged into that numerator. 7 minus 6 is a positive 1, so it's positive. 7 plugged into the denominator. 7 plus 2 is 9. That's positive. A positive divided by a positive is a positive. Is that greater than 0? You bet it is. Okay. So my interval, everything shaded, is negative infinity to negative 2, parentheses, union 6 to infinity. And we're leaving out that middle interval right there. So for 13e, we have another rational inequality. Why do I say that? This guy right here is the inequality. Rational is because we have a variable in the denominator. Now, remember the first step? You need a 0 on one side. Got that. Next step, you need everything factored. Hey, we got that too. Look, the top's already factored for us. So we're ready to just straight away draw a number line. What goes on the number line? Well, any 0 from the top or the bottom. Like if I set x plus 1 equal to 0, that gives me x is equal to negative 1. I need to include it. If I set x minus 2 equal to 0, that gives me x is equal to 2. And then you also need to use the denominator. If I set x minus 1 equal to 0, that gives me x is equal to 1. So let's include all those. You got to go smallest to largest. So negative 1's on the left, then 1, then 2. Again, where I put these, they have to be in order. That matters. But the distance, really, 2 should be a little farther over. Actually, closer to here. There's 2 between here. So these two should be closer together. But that's not important. You just need to shade. Okay, now. How about open circles or closed circles? If it came from the numerator, you need a closed circle in this case because of the equal to. But when it comes from a denominator, I don't care what's right here, as long as it's not an equals, then it's an open circle on your number line. So negative 1 gets filled in, positive 1 is open, 2 gets filled in. Looks like a heart. Okay, now we're going to test points, and this is why I get to play with all my fancy colors. You don't need fancy colors to do this, though, right? A number in this interval would be, say, x is equal to negative 2. Let's go ahead and plug it in. So, ooh, somebody's in my front door. Hold on. Okay, sorry for the interruption. Here we are. I'm going to take negative 2 and plug it into x plus 1. Now, negative 2 plus 1 is a negative number, right? We're multiplying it times x minus 2. So negative 2 plugged in there is a negative 4, which is a negative number. When I plug negative 2 in the denominator, I also get a negative number, negative 3. Now when I multiply negative times the negative on top, that gives me a positive. And then in the bottom, we have a negative. And a positive divided by negative overall is some negative answer. And all the while, this has got to be greater than or equal to 0. But is that true? Is a negative number greater than or equal to 0? Tis not. So I cross that out. And then I change colors and I move on to the next place. Okay? A number between negative 1 and 1, my favorite is 0. So if I take 0 and I plug it into x plus 1, it's positive, right? If I take 0 and plug it into x minus 2, it's negative. If I take 0 and plug it into x minus 1, it is negative, okay? Now, a positive times a negative is a negative in the numerator divided by a negative. A negative divided by negative overall is positive. Now, again, I'm asking, is that greater than or equal to 0? You bet it is, so I shade all that in. Now, again, if these cute little tricks are not working for you, actually plug it in. Instead of putting positive, put 1. Instead of putting negative, put negative 2. Instead of putting negative, put negative 1 and calculate it, and you're going to get a positive number, and you know that's greater than or equal to 0. Okay? Now, here, this one's not any fun, but it's still totally doable. And with my trick, it makes it easier. So if I plug in, let's for instance, 1.5. You like that? Something between 1 and 2. Because we know there's a whole infinite amount of numbers between 1 and 2. So 1.5 plus 1, that's positive. We don't care what it is, we just know it's positive. But 1.5 subtract 2, that's going backwards. Think you got $1.50 in your bank account and you minus $2, you're in the hole, right? So that's negative. 1.5 minus 1, you're still left with 50 cents. So that's positive. Now, a positive times a negative in the numerator is a negative. Divided by a positive, a negative divided by positive is a negative. Is that greater than or equal to 0? Nope, right? That's out. Negatives are not greater than or equal to 0. Now, I know you're assuming that over here, the 2 is going to be shaded in, and I could say that more than likely, it's going to be shaded in, but we're not dealing with likelies, like, right, we got to work this out, because these rationals can throw you off a little bit sometimes. Sometimes rationals right next to each other need to be shaded. So be careful. Same thing with polynomials, just depending on what the zeros are. So go ahead and work it all the way out. Check every interval. So I'm going to check. I need a different color. How about x equals 3? Okay, so 3 plugged into x plus 1 is a positive number. It's 4. 3 plugged into x minus 2 is a positive number. It happens to be 1. 3 plugged into x minus 1 is a positive number. It's 2. Now all these positives on top divided by a positive is overall positive. Is that greater than or equal to 0? Sure is. I'm going to shade that in. So when I write my answer, we're talking negative 1 to 1, but the negative 1 needs to be in a bracket, the positive 1 parenthesis, okay? Because the negative 1 was included because it came from a numerator, and it's greater than or equal to 0. And then union, and then the 1's not included because it came from the denominator. Over here, the 2 is included with a bracket, and then to infinity. And there's your final answer in interval notation. Okay, now this problem I would consider a little bit of a pain. And let me tell you why. We don't have a 0 over here, so I've got to move that over, right? So I've got x plus 3 divided by x minus 4 minus 5 is less than or equal to 0. But see, here's the problem. All my cute little tricks are not going to work if I have two separate fractions. So I have to find a common denominator and combine this together. I don't know how much of this shows up in your homework. It doesn't make for a great test question to me. But I still need you to know how to do it. So let me just be quiet and do the problem. So I'm going to multiply by x minus 4 over x minus 4. So we have a common denominator. Let's use yellow. I haven't used yellow in a long time. So here we go. Right here, x minus 4 over x minus 4. Excuse me. Okay, now. I've got x plus 3 from here. Now I'm distributing this minus 5. So minus 5 times x and minus 5 times negative 4 is plus 20 over the common denominator of x minus 4. That's less than or equal to 0. I need to now add like terms. So I've got an x and a minus 5x. That's minus 4x. And I got a 3 plus 20. That's plus 23 over x minus 4. Now what do I do? Well, now it looks like the rest of the problems, except we just got something ugly on top. So I'm ready for my number line. What goes on my number line? Well, from the denominator, I've got, change colors on you, I've got x is equal to 4, right? X minus 4 equals 0 gives me x equals 4. But from the numerator, I've got negative 4x plus 23 equals to 0. Could have picked better numbers. And that's going to subtract the 23. That's negative 4x equals negative 23. Divide by negative 4. And that's going to give me x is equal to positive 23 over 4. Not pretty. If you like to think about it as a mixed number, 4 goes in 23 5 times, so that's the same as 5 3/4. Although 23/4 is really better than that. Now, those are the two values that go on the number line. So 4 goes on the number line, and 23/4, which is bigger, goes on the number line. Now, the one that comes from a numerator, you decide whether it's filled in or open based on your inequality. Uh-oh, low battery. Hold on. Okay, so, sorry about all the interruptions. Now I'm plugged in, ready to go. So again, from the numerator, your inequality matches, or your filled in matches the inequality. Because it has an equal to, I'm going to fill in 23 thirds, if it will let me. There it goes. From the denominator, I don't care what the inequality is. It can't be equal to 4, so that's open. Now we just got to test values, right? Something's on the left of 4. The easiest thing I can think of is 0. So I'm going to plug in x equals 0. Something between 4 and 23/4. Remember, 23/4 is 5 3/4. So 5 would work. Matter of fact, that's the only whole number between the two. So let's do x equals 5. And then I need something on the other side of 23/4. How about 6 or 7 or 8 or anything like that if you want to, just not 23/4. So that's going to be x is equal to 7. Okay? Now, let's take 0 and plug it in to, can't go with the original inequality, because if you have a positive over a negative less than or equal to 5, that's just not going to be what we need, because when it's positive, we won't know if it's true or false. You've got to look at the one that's got the 0 on. So I'm looking at this situation right here. All right, so if I plug 0 into this numerator, negative 4 times 0 plus 23 is a positive 23. 0 minus 4 is a negative 4. Is that less than or equal to 0? It is, because a positive divided by a negative is a negative. So this part gets shaded in. Now I'm going to check 5. Okay, so 5 plugged into the numerator. Negative 4 times 5 is negative 20. Negative 20 plus 23 is 3. That's a positive number. But 5 in the denominator, 5 minus 4, hey, that's also positive. Positive divided by a positive is a positive. Is that less than or equal to 0? No, it's not. So I'm not going to shade that in. Now, again, looks like they usually alternate, like on shaded, not shaded, shaded, right? Best bet is this is going to be shaded, but it's not guaranteed. So you do have to check it. All right, so I'm going to, and I take 7 and I plug it in up here. Negative 4 times 7 is negative 28. Negative 28 plus 23 is a negative 5, so it's negative in the numerator. 7 minus 4 is a positive 3, so positive in the denominator. Negative divided by positive is negative. Is that less than or equal to 0? It is, so I shade right here. Okay, so what's shaded is my answer. That's negative infinity to 4, parentheses, union 23/4 to infinity. And that 23/4, I have it wrong because it needs to be in a bracket, right? I can't get my pen to erase. There we go. There, now it's right. So pay special attention to the open and closed circles, if they should be open and closed to start with, and then when you write your interval. All right, so for another inequality, maybe our last one, I can't even remember. So notice we have a 0. That's a good sign. Do we have a problem that factors, or do we have to use the quadratic formula? Can I even use the quadratic formula? I can, because it's quadratic, because it's got an x squared, but do I have to? Well, multiplies to be 1 and adds to be 2. We can do that, right? That's 1 and 1. So it's x plus 1 times x plus 1 less than 0. So the next thing I need to do is find out where this is equal to 0. So x equals negative 1 from here. Hey, x equals negative 1 from here is one of those problems that has multiplicity. Now, I don't have 2 numbers to put up here. I only have the 1 number to put up there. Open or closed? It's open, right? Because there's no equal to here. Now, I just need to test points. So on the left side, let's test about x is equal to negative 2. And on the right side, let's test x is equal to 0, right? Let's go ahead and plug 0 in because I still got my blue pen working. So 0 plus 1 is 1, so that's positive. 0 plus 1 is 1, so that's positive. But positive times positive is a positive. Is that less than 0? Nope, so we don't shade that side. All right. So for x equals negative 2, let's do it again. Negative 2 plus 1 is a negative 1. Again, if you need to do it all the way out with numbers like I'm doing here, that's fine. Negative 2 plus 1 is negative 1. Is that less than 0? Well, negative 1 times negative 1 is positive 1 less than 0. Nope. Now, if you did it the quick way, it would work just like this. A negative times a negative is a positive, and positive is not less than 0, so I don't shade that in either. And then when you take a look at your answer, absolutely nothing is shaded in, not even -1. Nothing is shaded in. So you know what that means? It means we don't have any solution to this. There are no numbers that will ever make this true. There's no solution. Or the empty set. You don't have to put both. But there are no numbers that will make this inequality true. So that's it. Oh my goodness, it's not the last of the inequalities. I've got 2 more. So this is the same as the last problem. It factors x plus 1 times x plus 1 is less than or equal to 0, right? So x equals -1. If you need a better explanation of that, just back up a couple of minutes and look at the problem before. So I put -1 on my number line. But what's different is the equal to part. This is filled in. Now, if we test over here on the left, say for instance, let's plug in -2, and over here on the right, let's plug in +2, okay? 0 would work fine also. If I take 2 and I plug it in here, that'd be 3 times 3 is 9. Or a positive times a positive, is that less than or equal to 0? Well, no, so I don't shade that in. On the other side, we're doing -2. So -2 plus 1 is a negative. -2 plus 1 is a negative. A negative times a negative is a positive. Is that less than or equal to 0? Nope. But now this time I have something shaded in. It's just the -1. Whenever you only have a single number as your answer, then instead of putting in an interval, because it's not an interval, it's just a single number, you put it in braces, and that tells you you have a set, and the set just includes the number -1, and that's all. Now, I truly think this is the last inequality that we have. So we need a 0 on one side. We've got that. That's good news. We need to factor if we can. We can't. X squared plus 16 is the sum of squares. It doesn't factor. But I still have to find where the top and the bottom are equal to 0. So when I look at the numerator, where's x squared equal to 0? I take the square root of both sides. I get plus or minus the square root of 0, which is 0. So that's going to go on my number line. Okay? I don't want to put it on there yet, though. I said x squared plus 16 equal to 0. I subtract the 16 to get -16. I take the square root of both sides, plus or minus. That gives me plus or minus 4i. But 4i is not a real number, and this right here is a real number line. Okay, so these are just like x-intercepts. We ignore them when we're talking about graphing on a real number line. Okay, so this doesn't matter. The only thing that goes on here is 0. Now, is it open or closed? It's open, right, because there's no equal to here. And again, I want to test points, so I want to change colors. Let's check -1 over here. And on the other side, how about +2 or +1 would be fine. I'm plugging that into my original problem because it's all I got. I've got 2 squared in the numerator and 2 squared plus 16 in the denominator. Notice I'm not using my trick. You could think through this, but if you don't have a problem factored, maybe avoid the trick. That might keep you out of trouble. So greater than 0, 2 squared is 4. 2 squared is 4 plus 16 is 20. Is 4 over 20, which of course is the same as 1/5. Is that greater than 0? You bet it is. So I shade that in. Okay. Now I'm looking on the other side, on the green side, -1. So I plug in -1 in the numerator. That's -1 squared. I plug in -1 in the denominator and add 16. Is that greater than 0? Well, -1 squared is 1. -1 squared is 1 plus 16 is 17. Is 1 over 17 greater than 0? Sure it is. So look, my answer is everything but that 0 right there. So when I write this in interval notation, I'm just saying -infinity to 0 with a parenthesis, so I don't include it, union 0 to infinity. And we're finished with the inequalities finally.